I thought I'd do a little introductory thing on modeling for 3D printing. That is to say, this is for beginners. This is not for people who are already familiar with the restrictions and the ways to get around modeling for 3D printing. Okay, so as you can see here on my screen, I've got a T. If this were, assume that this grid down here is a 3D print bed. This would not print well without, it wouldn't print at all, really, without support material. Support material is like scaffolding. So, let me show you, do a quick explanation here of that. Scaffolding would consist of small amounts of material out on the end and maybe even multiple pieces, you know, like this. Okay, the reason is because your 3D print head cannot just like print into space. So it's basically, it drops liquid plastic down, or molten, it's not really liquid, it's molten plastic, but it drops molten plastic down. So if there's nothing for it to land on, it's just going to drop all the way down to the heated bed. Okay. However, we can do things to fix this. So let's delete this. If this were my model, and I did want to print this, and I don't want to use support, what I can do is lay it down on its side like that, and then lay it on the printed bed. See, now that would print without support with no problem. Now, there are other shapes and things to consider. Let's do a box real quick, and let's see what kind of limitations we'll run up against here. So this is my box here, but what I want to do is I want this edge to go like this. Okay, well, 45 degrees diagonally is considered the normal limitation that you can print without support. Okay, so you need to think about that when you're designing something. So if you wanted to print this with this like way down here, this could be an issue. I think right about there is about 45 degrees. Okay, 45 degrees is on the borderline of, yeah, it'll print, yeah, it won't print, depending on your printer's capabilities. So as you can see, that's leaning over quite a ways. 45 degrees is where most support would automatically kick in if you've got it turned on. Okay, so if you go up from 45 degrees, if you make this slant more this way, so it's less than 45 degrees, most printers, at least a good tuned printer, will print that. Now, that being said, this edge up here may have some little blurbs on it that you have to clean off either with a little sandpaper, a little file, or a knife. Because it's going to, when it comes over, it's going to print a little bit further than the last layer. So there may be a little blooper there, called a little blip, a little wart. The further you come out, the better the item will look. Now, if you want to print something out like this, it's okay, but you should add support in here for that. Now, curves are a different matter. Let's go to another layer here. If you were to print something like a ball like that, and I'm going to delete this half, and then I'm going to use, I got a program here called Thicken. Oh, there it is right there. Okay. Okay, so I've screwed up because I don't have an edge on that. But let's assume that this were a shell like this. This, if your printer is calibrated well, this would actually print, because it would go up here, and up here it might have a little bit of bloopers in it, you know, a little bit of blobs in it, but this would probably print okay. So that's some of the things to think about when you're designing for 3D print. Now, a lot of times people like to have bevels and stuff. Let's assume that you make a box like this, and you want to have a nice bevel on it. So you go, let's see, no, that isn't what I wanted to do actually. Let me do this one more time here. Create a box, numeric, and I'm going to just do it like a rounded corner on it, like that, and a bevel. Okay, so let's assume that you have this box, and this can either be a bevel, like I show here, or if this corner were rounded. This is all fine, except down here where it's sitting on the print bed, this could be over a 45, and so this edge may look bad. So either make sure that this edge is less than a 45, or make it very small, or make the bottom flat and don't let it be a bevel, because nice rounded edges look nice, except when they're done on the bottom. Okay, so let's do that again. Numeric. Oh, and what I wanted the box. Numeric. Now this time I'm going to give this a bunch of segments there to be rounded off. Okay, and so when you're looking at this, that's a nice rounded box. But the chances are that this bottom edge is just going to look bad. So if you want rounded edges, I would say stick with them on the sides and the top. They'll print fine there. But the bottom, wherever it's rounded like this, is going to have a problem. Okay. Next thing. Let's assume that you have a problem with your print sticking. The corners always come up. Of course, you can print with a brim. You can print with a raft, things like that. You'll learn what those are later. But one of the things you can do is to help attach a corner a little bit better is you can put something like this, a little disc, and I put that too far out. So you put a little disc like this on each corner, and what that'll do is this will stick very well, and it'll keep this corner. It's usually corners that want to pull up first. Yeah, they may pull up and come all the way back to the middle, but it's the corner. If you can keep the corner down, you can keep the rest of the print down usually. So if you add a little tab like this, you make it just one layer thick, 1 or 2 layers thick. So if you're printing with a 0.35 millimeter nozzle, make it 0.35 millimeters thick. If you're printing with a bigger nozzle, then of course you have to make it that size. But if you put one of these on each corner, it will help hold this down. And when you're done, this can easily be removed because it'll be thin. It'll be about, it'll be 1 layer thick. So you can just use a sharp X-Acto knife to cut that off real easy. And it's a quick, easy way to help hold your parts down. Another thing, almost every slicer on the market does not make holes the right size. Okay, so there are all kinds of templates that you can download and print so that you can get an idea of what size it will be. But just to give you an idea of what I'm talking about. Okay, if you design a hole and something is supposed to fit in that hole, I didn't even draw that round, it's kind of oval, but that hole is going to be the wrong size. Now there are multiple reasons for that. For one, you're making it with straight lines, and so you can imagine that the hole's on the inside, and every time a line goes straight, it actually cuts a little bit of a corner, so to speak. It would be like if this was part of your hole, it's a line from here to here, so it cuts the corner. That makes it smaller. But the bigger influence is the fact that the plastic shrinks a little bit. Now, most printers can print the outside the right size, but by the time you get to the inside, everything starts shrinking and pulling towards that outside layer, and the holes are smaller. How much smaller? Well, that's the million-dollar question. It can be anywhere from 0.5 millimeter smaller up to 2 millimeters smaller. Well, that's why we have little guides that you can print. Go into Thingiverse, look for hole size guide. I've got one that's very simple to print. It's only like 3 millimeters thick, so it doesn't take a lot of plastic. And I've got from 1 millimeter hole all the way up to like 26, 28 millimeter hole. So if you're going to make something for something around, let's say you're going to make a battery holder, what you would do is you would print that guide out and keep it. And then when you want to make something round that fits, you print the outside first, or you take whatever it is that's going to have to go in the hole, and you put it through the template and see what size hole you need to make. And so 1 to 2 millimeters is a normal excess. Actually, it's more closer to 1 millimeter for the average hole, but it all depends on the size of the hole. Like a 1 millimeter hole will probably print solid. A 2 millimeter hole will print like a pinhole, but when you get up to like 3 and 4 millimeters, then they become a normal hole. So that's another item that you can look at. In fact, let's see here. Let me see if I can find the template that I created. Okay, let's go. Hole size. Yeah, here we go. Okay, so this is the template that I have on Thingiverse. And it starts off here. Let me grab mine so I can actually look at it. It starts off here at 1 millimeter and goes all the way up to this one, big one here, and that's 25 millimeter. And I go up in 1 millimeter increments. So that's 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, and so on. And so you can download this, and as you can see, it's very thin. So it's easy to print without a lot of material. You can even print it with some infill or whatever, but it's only 2.5 millimeters thick. I'm looking at it right here. So you can print that solid and it's fine. But you need a tool like this to find out what hole size that you're looking at. So you can take a real world object and put it in each of these holes. And what I do is I just took, because text is a little hard to do on some printers, I didn't try to put the sizes next to these holes, but I have them listed on Thingiverse. And so what you can do is you can take and write in a marker next to each one of these. I just used a fine Sharpie marker and wrote the size, and it zigzags like this. It goes from here to here, and this one's next, and it goes up to there, then this one's the next bigger one, and go up to there, and so forth and so on. So this one's the largest hole in here. And so you can use this. It's got a fair number of walls. If you want to see, let me show you here. It's got a fair number of walls around the outside edge, so that gives you the best chance at a round hole. In fact, the larger ones have more higher numbers of polygons around the edge than the smaller ones. But this is a really good thing to get you very, very close. You may still have to print a few. When you've got something that, like, you need to fit really tight, you may still have to print a few of them before you get it exactly right. But this should give you a good example of sizes. And if the thing doesn't have to fit really tight, you know, if it's not real close tolerance, this will get you right on the money then, you know. Anyway, I thought I would just do a quick video tutorial on some of the things about 3D printing and how to design for 3D printing. This, in case anybody wants to know, this program I use up here is called Lightwave. It's a very expensive program, but these methods, these things I'm telling you, can be used in pretty much any software that you want to use to design in. And I had to learn a lot to get my designs to print. I've been doing 3D modeling for 25 years, and I had to completely relearn everything, because when you 3D model for what I was doing, it didn't matter if you had something that had an open edge or whatever. So like if I had this and there was a missing side, and this is the side I was going to render from, it didn't matter. But you can't do that with 3D modeling or with 3D printing, because it matters. This won't print. Why? Because it's not solid, or it's not what they call manifold or watertight. And watertight, manifold is a more precise term, but watertight is a term that you should be able to understand, because it means that if this were a vessel and you were to turn it up on its end, you couldn't hold water in it because there's an open area. Even if the open area is microscopically small, if those aren't connected, you can't hold water in it. So, this is just a quick tutorial. If people like this set of tutorials, I'm going to continue to make more, and I'll get more in depth. I'll even show printing and tips and tricks for that. So if you want to see something either in the modeling section or in the 3D printing tutorials or informations or how-tos or just answered questions, please ask me in the comments down below, and leave a like if you would. I really appreciate it. It helps me out. It allows me to do more of these if you leave a like. So thank you very much, and I'll see you next time.